Hey guys, we're up to 6.5, examples 2 and 3 from my examples. Go get your graphing calculator. And throw in actually example 3 first into your R equals. Make sure you are in polar mode and in radians. As you can see, you're going to end up with a football shape at first if you do zoom standard, so we're going to fix that. I'm going to hit zoom 5. I'm also going to zoom in to get a better look at this thing. And as you can see, we have a circle with a diameter of 3, and it's on the x-axis. It's symmetrical over the x-axis, starting from the origin and to the right. And our job right now is to sort of explore why it looks the way it does. The first thing I'm going to do is sketch it roughly on my polar graph. Let's go ahead and do that. So 1, 2, 3, right? And so roughly the circle looks something like that. It's a pretty terrible circle there, but no worries. You guys get the idea. The other thing I'm going to actually do is draw in a regular cosine function. Just a rough sketch. So cosine, as you guys know it, at 0 starts at its maximum. And actually, let's get 4 sections in here. So start at its maximum. Cosine of 0 is its max. Pi over 2 at its mid, then goes down to its min, back to its mid, and then up back to its max. Rough sketch of cosine, all right? Now, how does this relate to our graph r is equal to 3 cosine theta? How does this relate to our polar graph of cosine? Well, let's take a look at how these things are drawn. First of all, we have to understand that at 0 radians, cosine is 3 units up, right? So here's 0 to 90. 0 to 90. At 0 degrees or 0 radians, I'm 3 units away from the pole. In this directed angle, I'm 3 units away from the pole. So that's why I'm starting at its maximum on the x-axis to the right. But as I go from 0 to 90, I start getting closer to the pole until the radius value now is at 0. So at pi over 2, I'm at the pole. Well, think about it. If I start at 0 degrees at its maximum radius at 3, if my radius never changed, I would just draw a quarter circle like that. But instead of doing a quarter circle always with the radius of 3, my radius is pulling in and getting closer to the pole as I get to 90 degrees, right? 0 to 90, it's going in. So that's why you get this top half of the circle for your polar graph. Now, what's more interesting now is this part. This is from 90 to 270. I'm sorry, 90 to 180, apologies. From 90 to 180, I'm at 0 and I go to a maximum, or sorry, go to a minimum. I'm 3 units away from the pole right over here at pi. But what's interesting is I don't see anything here, right? I don't see anything over here, and I don't see anything in quadrant 2. This is quadrant 2, right? But here's the thing. You are a negative distance away from the pole. You are 3 units away from the pole by the time you get to pi. A negative radius means that instead of drawing anything in quadrant 2, a negative radius means you draw in quadrant 4. And so if you think about it, initially you had a maximum of 3 and you were drawing the top half of the circle, right? That's this part. But once you're over here, you start at 0. Remember, we end up at 0 by the time we're at 90 degrees. Here's your 0, 90 degrees, but then you end up drawing to its max again. So instead of drawing in quadrant 2, we draw in quadrant 3, and we draw the bottom half of the circle. So we go from 0 units away from the pole to 3 units away from the pole. But again, it gets drawn in quadrant 4 instead of quadrant 2. Then we're in from 180 to 270. We're going from 3 units away from the pole back to 0 units away from the pole. But again, because it's negative, I don't draw in quadrant 3. Or sorry, I should write 3. If I have a negative radius, quadrant 3 stuff gets drawn in quadrant 1. And so remember, quadrant 3 is from its max to its min. Its minimum to a 0. So I'm 3 units away from the pole in the negative direction. So I'm 3 units away from the pole. So instead of writing it here, I'm over here because it's negative. And then I end up getting close to the pole. But again, I'm not drawing it in quadrant 3. I'm going to draw it in quadrant 1. And then finally, we're drawing this part. This is quadrant 4 from 0 to 3 units away. So here's 0, and slowly I'll go 3 units away. But this time I'm actually in quadrant 4. I don't draw it in quadrant 2 because this is positive. So what has happened is this is what I draw in quadrant 1. This is what I draw in quadrant 2. This is what I draw in quadrant 3. And this is what I draw in quadrant 4. And that's how 3 cosine theta ends up being drawn as a polar graph. Let's look at sine. And again, let's do a rough sketch. Four sections. Sine starts at its mid, goes to its max, goes to its mid, goes to its min, goes to its mid, and rough sketch. The key thing to notice here is that sine starts at 0 at 0. So you're at the pole at 0, so you won't see the circle extend itself this way. No, you'll see it extend itself to its maximum to draw the circle at 90 degrees or pi over 2. So this is pi over 2. This is where 1, 2, 3. This is where your circle is going to get drawn. And then obviously quadrant 2, it's still positive, so I will draw quadrant 2, but notice it'll go to its maximum, and then as it's traversing to pi, it's going to pull in and then end up drawing a circle like that. And in quadrant 3, it's negative, so it'll draw this part of the circle again. And in quadrant 4, it'll draw this part of the circle again. So it'd be quadrant 1, quadrant 2, quadrant 3, quadrant 4. And we can do a quick sketch. Okay, again, rough sketch. I know it's not great looking, but that's the general idea. Now, what do you want to get from these two basic graphs? Because these aren't the main graphs of the section. But what's really important to understand is that sine is going to be symmetric over the y-axis always. And cosine is going to be symmetric over x-axis always. This is going to be really useful when we get to odd frequency Rose curves and the cardioid or the Limason curves. And also do recognize that if you have a maximum here, this is your initial max here. And obviously, if you have your max here, that's your max here. All right. So those are the corresponding maximum points. Everything else kind of follows along. If you understood this concept, it really will go along to helping you understand how these graphs are the way they are. Now, you won't actually be asked a ton to graph these, but recognizing them and being able to tell the characteristics by looking at the equations, hopefully this will support your understanding of why, so it's not very hard to memorize any of this. And again, generally speaking, understanding the symmetry is the key thing to remember. Okay. I'll see you guys in the next example.